Okay, hi guys, my name's Rob and I'm a civil engineering student. I'm going to take you through sort of one of the more unusual but coolest parts of engineering, and that is types of radiation. So you may have heard of this before from one of your exams, or you maybe wanted to revise from this, or just want a bit of help understanding things. But believe it or not, engineers can spend their whole lives trying to protect you from this stuff. It can be really dangerous if you don't look after yourself around radiation properly. So what is all this radiation stuff? Well, radiation is found everywhere. In fact, if you take matter, which makes up everything around us, you get particles within that, which are bound chemically. And then within that, we get something called nuclei. And within that, we get something called protons and neutrons, which are tiny, tiny little particles that are 0.1 meters wide. They're tiny. So radiation is released when these nuclei, so protons and neutrons, have too much energy and are way too excited. So they need to get rid of some of that energy, and it's released as radiation. There are three types of radiation, which all release different amount of energies. Now, these three types are alpha, beta, and gamma. Alpha is made up of 2 protons and 2 neutrons, and actually it's a helium nucleus, which can be found in balloons that float around at parties. Although tiny, in radiation terms, they're massive. This means that matter can easily absorb them. So maybe a piece of paper, or about 30 centimeters of air could stop these things, which is about the size of a ruler. So next is beta. Beta are actually tiny little particles called electrons, which have a negative charge, as shown with the magnet. Because beta radiation is smaller than alpha, it wriggles through matter more easily, so it needs a thicker piece of aluminium to absorb it, or about 1 meter of air. Finally is gamma. Now these are just tiny, tiny waves, with a little bit of energy. This little bit of energy is known as photons, because they act like little packets. Einstein suggested this idea in 1905. They also travel mega quick, about 300 million meters a second, so a bit faster than your family car. Now because they're so small, they actually need a big chunk of lead to absorb them, and can travel for hundreds and hundreds of miles in air before they're absorbed. Okay, so thanks for watching guys. These sources helped me, so they may help you too if you want a bit more information on the subject, but after that I just hope you've enjoyed the video.